A single circular edge, a fraction of a millimeter wide, decides whether a printed logo lands crisp or smeared. It rides across a steel plate thousands of times an hour, wiping away every trace of surplus ink and leaving color only where the image is etched. That edge is ground from tetragonal zirconia. Seated at the mouth of a sealed ink cup, the pad printing ceramic ring does two jobs at once. It seals the ink reservoir against the plate, and it meters each pass of ink. Its edge condition sets the print quality, and its wear life sets how long a run continues before anything is replaced. What keeps that edge sharp through a long run is hardness. Yttria-stabilized tetragonal zirconia reaches a Vickers hardness of roughly 1,300, several times that of hardened tool steel. The harder edge abrades far more slowly against the steel plate, and a slower wearing edge holds its metering geometry, which is why a zirconia ring commonly outlasts a metal one by several times over the same run. A second feature matters just as much as hardness: the surface itself. A finely polished zirconia face is self-lubricating and does not wet to solvent-based inks, so the blade glides over both steel and polymer plates and releases ink cleanly at the end of each stroke. Because zirconia is chemically inert, the same face resists the aggressive solvents used to thin printing inks, staying dense and bright rather than pitting over time. The metering edge is thin by design, so the material behind it has to carry the contact load without chipping. Tetragonal zirconia answers with a flexural strength near 1,000 megapascals, among the highest of any oxide ceramic. That reserve lets the edge be ground fine enough to doctor cleanly while still surviving repeated snap contact with a hard steel plate. A property alone does not explain why this ceramic resists the chipping that ends a metal edge. The answer sits in the crystal structure. At room temperature, the zirconia grains are held in a metastable tetragonal form. When a crack begins to open and its stress field reaches a grain, that grain transforms to the monoclinic form and expands by about 4% in volume. The expanding grains press inward on the crack faces and arrest the crack before it can travel. This mechanism gives Yttria-stabilized zirconia a fracture toughness in the range of 7 to 11 megapascal-root-metres. Roughly 2 to 3 times that of alumina, and enough to keep a fine edge intact under repeated impact. It is the same toughness that lets the ring taper to a sharp doctoring line without becoming as fragile as a carbide edge of the same thinness. On the plate, that combination, hardness to resist wear and toughness to resist chipping, is what turns a thin ground edge into a long-lived sealing line. The contact edge can be held at around 0.15 of a millimeter, fine enough to wipe cleanly, yet backed by enough material to shrug off the snap loads of continuous printing. Diameters cover a well-established ladder rather than a single figure. Round rings run from roughly 40 mm up to about 210, with 90, 100, and 120 mm among the most common. Each is specified by 3 dimensions: outside diameter, inside diameter, and height. A 90 mm ring, for instance, typically measures 90 across the outside, 82 inside, and 12 tall. Beyond diameter, the edge profile is what matches a ring to a machine. A single-sided blade carries 1 doctoring edge. A double-sided blade carries 2, doubling usable life by flipping the ring. The body can be round or oval to suit the artwork, and the taper can be ground as a single edge, a double edge, or a wedge. Where an ink cup falls outside the standard ladder, outside and inside diameter, height, and blade angle can each be machined to a drawing after sintering. The defining use of this ring is the sealed ink cup of a pad printing machine. As the cup slides across the etched plate, the ring floods the image with ink on one pass and wipes the surface clean on the return, leaving ink only in the engraving for the silicone pad to lift and transfer. In that single roll, the ring delivers several things at once: sharp, consistent prints, long edge service life, clean solvent-resistant face, sealed, low evaporation cup, gentle on printing plates. A hard, tough edge doctors the same fine line print after print, so image sharpness holds instead of drifting as a run continues. Because the edge wears slowly, one ring carries a long run before replacement. Its self-lubricating, chemically inert face sheds solvent inks and cleans easily, while the tight seal against the klitsch keeps the reservoir from drying and holds ink viscosity steady. And unlike a sharp carbide edge, the tapered zirconia edge glides over photopolymer and steel plates without scoring them.